Right. We do the last question. Question number 12. They say to us, define oxidation in terms of electron transfer. How they say define is very important, how they end their statement. Okay, it's very important. They can say define oxidation in terms of oxidation number. But here they say define oxidation in terms of electron transfer. Right. 12.1. Oxidation in terms of oxidation in terms of electron transfer. It is the loss of electrons. Easy as that. That's how we define it. This is the oxidation in terms of, I'm emphasizing, guys, oxidation in terms of electron transfer. This is how we describe it. But oxidation in terms of oxidation number, how do we define it? We say it is an increase in oxidation number. Do you hear the difference? I want you to note them down, okay? Note and write on your paper, oxidation in terms of electron transfer. This is the definition. This is how we define it. Oxidation in terms of oxidation number, it is the increase in oxidation number. I hope you wrote it down. Right. 12.2, they say, the reaction between dichromate ions and ion 2 ions, which is Fe2 plus ion, in an acid medium, it gives the following. In an acid medium, write down the oxidation number of chromium in Cr2O7 2 minus. A lot of people, they know that the oxidation number is 6. They can just write 6 and get away with it. You are done. But some people, they do not know how to get that 6. Let me show you quick. So to answer 12.2.1, they say right, we can calculate. So Cr2 plus O7 is equals to the net ion of the compound. It's gonna be -2. If here it was nothing, it was gonna be 0. Okay, so now we're gonna take this as a coefficient, these two as a coefficient. Cr, it's what we are looking for, and then we're gonna take 7 as the coefficient. But what is the ions for oxygen? It's -2. We all know that, right? Is equals to -2, and therefore here we have 2Cr. This multiplied by that will be -14 is equals to -2. And then we have 2Cr will be equals to, we transpose 14 to the other side of the equation, -2 plus 14, we get +12. And then we divide both sides by 2, Cr will be +6. So that means we have Cr positive 6 plus over there. You start with the number inside. Okay, 6 plus. If you forget how to write this thing, take hints from here. You write number and positive here. Okay, if you forgot how to write it. So you can calculate it like this, or you can just write 6. It's 1 mark after all. But this is how you actually determine the oxidation number for chromium in dichromium ion. That will be 12.2.1. 12.2.2. They say to us, write down the formula of the substance that undergoes oxidation. Explain the answer in terms of oxidation number. So basically, this is the same. This is you see how I said 12.1. You see how I said 12.1. I said to you, define oxidation in terms of electron transfer, loss of electrons. Sometimes they can say define oxidation in terms of oxidation number. This is the same as that, but now we're going to talk in terms of oxidation number, because they say write down something that undergoes oxidation and then explain that in terms of it's the same as saying define oxidation, but here you see, I don't know if you get what I'm saying. So write down the formula, but here we're starting by writing down the formula. So let us start by explaining it so that we can see how to write it there. Let us start by explaining it first. Ne? I'll leave the space there for formula. What is the how do I explain in terms of something that, what is oxidation in terms of oxidation number? I'm going to say but you're gonna need to do it, but it's fine. Let me show you. So Fe2 plus Fe3 plus. These numbers, we call them the oxidation numbers. Cr2O7, we have this. H, we have that. H is there. Cr is there. Now, let us talk about Cr. Cr here, what is the oxidation number for Cr? We said it's positive 6. We have just calculated it, right? It's positive 6. Now, what is the oxidation number of Cr on that side? It's positive 3. It's positive 3. I'll just write it like positive, not 3 plus. Okay, let me just say it's 6 plus. It's 6 plus. And then here is 3 plus, right? Okay, sharp. What is the oxidation number of oxygen here? It's 2 minus. And on this side, it is also 2 minus, okay? It's also 2 minus. And then for hydrogen here, it's positive 1, okay? Now, for Fe here, it's positive 2, there is positive 3. H, it's plus 1. It's 1 plus, and also there is 1 plus. Now, let's talk about oxygen. Oxygen is 2 minus, and then this side is 2 minus. It is the same. The oxidation number doesn't change. It is constant. And then H, the oxidation number for hydrogen, it's 1, it's positive 1. Again, the hydrogen, it is the same. So those ions or those atoms, we call them the spectator ions. When the oxidation number is not changing, we call them the spectator ions. They are just there. They are not involved, like they do nothing in this reaction. They are the spectators. They're just sitting there watching the reaction taking place. We call them the spectator ions, okay? Spectator ions. Sometimes they can say, give the spectator ions. You're going to say it's oxygen and your hydrogen, O and H. Those are your spectator ions. Now, let's talk about Cr and Fe. Cr, here we said it's 6 plus. We say in Cr, it's 6 plus. So now, Cr to Cr, what happened to the oxidation number? The oxidation number decreased. The oxidation number decreased. The oxidation number went down. Let's have a look again at Fe. Fe here we have 2 plus, and then here we have 3 plus. Now, what happened to the oxidation number here of Fe? Oxidation number increased from 2 to 3. That's an increase in oxidation number. So now, a species that undergoes oxidation, write down, these are the notes, né? Oxidation, I'm writing the notes for you. Oxidation is when the oxidation number increases. Reduction is when the oxidation number decreases. So that means chromium ion, the oxidation number is decreasing. That means it is undergoing reduction. Fe, oxidation number, is increasing. That means it is undergoing oxidation. Hence why this reaction, it is called redox reaction or reduction oxidation reaction. So they say write the formula of the substance that undergoes oxidation. Oxidation, again, it is the, remember, in terms of electron transfer, we said in terms of, this is oxidation in terms of oxidation number. But oxidation, guys, note down, these things are important. Oxidation in terms of electron transfer, it is the loss of electrons. And therefore reduction, it is the gain of electrons. Ne? This is the same thing, just that here we are explaining in terms of electron transfer, here we are explaining in terms of oxidation number. So now, which one is undergoing? Because we said it's Fe increases, I guess. So the formula will be Fe 2 plus will lose the electrons, right? When Fe2 plus loses the electrons, it loses on the product side. It will form what? It will form Fe, it will be now Fe3 plus. Can you see that? So they say write down the formula. Oh, sorry, not the equation, the formula. This is the equation. If they wanted the equation, you're gonna do this, ne? So let's read the question. So, but they want us to write not the equation, the formula, okay? Let's fix that first. It's that thing, we are done. Actually, it's that thing, not the equation. When they say equation, you write that. But write down the formula. When it's even highlighted, you see you can do mistake. The formula. So the formula will be, this is the formula, right? Will be this. This thing is the one that undergoes oxidation. And they say explain in terms of oxidation number. You're gonna say it undergoes oxidation because Fe, the oxidation number, decreased from where? From Fe2 plus ion to Fe3 plus ion. That's the, I said, no, sorry, increased, right? The oxidation number increased. I'm too excited. Increased from Fe2 plus to Fe3 plus. That's why, you see, that's why we say this thing, the formula for this thing, it undergoes oxidation. Right. I'm taking my time on this ones. Now, we move to question number what? We move to question number 12.2.3. Now, 12.2.3, it says to us, write down the half reaction. So write down the reduction half reaction. So we want the one that undergoes reduction. We saw that we have already discussed CR is the one that undergoes reduction. So half reaction for reduction, you can use this table. Okay, you can use this table to write the standard reduction potentials. I don't like using the table because I want to understand things. I will show you what I do, and I'll also refer you to the table if you are fine with that. Let me write it first and I'll show you other. It's 2 marks, so you don't have to waste your time. But if you want to understand how this thing was done, let me show you how. So we said CR is the one that is undergoing, where is it? We said CR, it is the one that is undergoing reduction because oxidation number is decreasing from 6 to 3, decreasing here, reduction. So this thing, which is CR2072 minus, when something undergoes reduction, what did we say in terms of electron transfer? It gains the electrons. So we gain the electrons on this side. This thing, it undergoes reduction. That means it's supposed to gain. We add the electrons to it. It gains the electrons, right? When this thing gains the electrons, It's gonna form what? It's gonna form Cr3 plus ion when it gains the electrons. I hope you agree with me on that one. Right. Now, we're gonna balance the atoms. How to balance the atoms? It's what you know. How many Cr do we have here? 2. How many Cr do we have here? We have 1. So we write 2 so that we can have 2. Another atoms that are missing is oxygen. We have oxygen on this side. This side, we need oxygen. But how many oxygens do we need? We need 7 oxygens. How are we going to introduce those 7 oxygens? You can see by adding water, because water has oxygen. So we need 7 molecules of what? Of water, so that we can have 7 oxygens. And therefore, the oxygens are now balanced. But us adding water, we added the hydrogens now again. And when you have hydrogens only on this side, we need hydrogens again on this side. How many hydrogens do we need? You're going to say 7 multiplied by 2, 14 hydrogens. So that means we need 14 H plus ions in acidic medium. And so why? Let me reduce my arrow here. Let me reduce my arrow here a little bit. We need 14 H plus ions. Now, is everything balanced? Let us check. Cr2, 14 hydro, this, right? We need 14 that. Just want to rewrite it nicely so that you can see it. Here we have, let me just write it there. Fast, hey, come on. So here it's electrons. And then here we said we need 14 H plus. So now let us balance. We have 2 Cr, 2 Cr. We have 7 oxygens, 7 oxygens. We have 14 hydrogen, 14 hydrogens. Now we balance the charge. The charge is what is these things by balance the electrons. So how many charges do we have on this side? We're going to have here, we have 1 electron, right? We have -2 from here, which is this, -1 from here, and then here we have positive 14, 14 multiplied by positive 14. So we're going to say -2, -1 plus 14. We have 11 this side. Total this side it is 11. Let us check this side. So here we're going to say 2 multiplied by 3. It's how much? It is 6 plus 0 plus 0. This is 0 because net charge is 0 there, 7 is 0. So this side it's 6. This side we have 11. So that means we need to reduce this side to 6 so that we can balance our charges, right? The charges are not balanced. Here we have 11, there we have 6. So what are we going to do? We use the electrons, right? So that means how many are we going to, if we write 2 over here, if you write 2, you're gonna have 2 electrons, so we're gonna eliminate by 2. So if we write, let's say 11 minus 6, how much do we need? We need 5. So that means we need 5 electrons over here, so that 5 multiplied by negative could be -5. Now we can say -2, -5 plus 14. Now we get 7. Oh, 6. So we're supposed to say 6 here. Let me see, we're supposed to say 6. Oh yeah, it's supposed to be 6 here, not 5. 6 so that we can get -6 there. So -2, -6 on your calculator, +14, we're gonna get 6. Now the charges are balanced. And therefore, this is the half reaction, and then we are done. If you can't do what I have just did right now, you can just refer to the table. And then here is the half reaction for what I have just did right now. Okay, can you see it? And then you can just do it like this. You can just take it from the table and write it there. It's 2 marks. You don't have to panic. Now, I don't like doing this. I like starting it from the scratch because I want to understand what's happening. So you can just write it like this. The way, don't panic, it's fine. It's not necessary for you to do it like this. You'll always be provided with that table. You can just take it from the table, just like that. Okay, right. That will be 12.2.3. That's half reaction of reduction. reduction. We said it's reducing. That's why we're writing it like that. Now, balance the above chemical equation using appropriate half reactions. Now we're going to have to balance. Now I'm erasing everything. Erase it. I don't want to erase this part, but it's fine. So to answer 12.2.4, we need to balance. So we need half reaction for oxidation. Half reaction for oxidation, we said we're going to have to write it. This is oxidation. Remember, this to that is oxidation. So it's Fe2 plus. Remember, oxidation is the lose of electrons. Hence why I'm losing electrons this side. And therefore, we're going to form, it's going to form, this thing after losing electrons is going to be Fe3 plus ion. Again, even if you don't know how to write this, you can take it from the table. Where is it? There it is. Babo, you're going to have to balance. This is not it. Let me show you. Where is it? Where is it? Oh, it's on. Oh, yeah, here it is. You see, you can take it from there. But remember, here, it's reduction. So whenever you are reversing it, you are doing oxidation. You have to go back to lose the electrons. Okay? Don't write it like this. You have to write it reversely because the reverse is oxidation, forward is reduction. Okay? So here is it for oxidation. And therefore, for reduction, we said it's, let me just copy it from here, Cr2, we said it's Cr2072 minus plus 14H, H plus 6 electrons, I remember, and the 2 Cr3 plus 7H2O. You see why I'm writing my electrons on the reactant side, because it is a reduction. It is gaining this thing. It is gaining the electrons. The electrons are on the product because it's oxidation. It is losing the electrons. Be careful here, please. So now they want us to balance this equation. So to balance the equation above, we have to add these two reactions, but we cannot add them yet because the number of electrons are not balanced. We need to balance the number of electrons. We can see we have 6 electrons over here. So that means we have to make this to be 6. So we're going to multiply this equation of oxidation by 6. So everything it's going to here for oxidation, we're going to have 6 Fe2 plus, and therefore this is going to be 6 electrons, and then this is going to be 6 Fe3 plus. Now we can add these two reactions. We can add them because the electrons are now balanced. Can you see? So this plus this, it's going to be Cr2072 minus plus 6 plus 6 Fe2 plus 14H plus, and then you see these electrons are this side of the reaction. It's like this will minus that, it falls off, and therefore on this side we have these reactants now, 2Cr3 plus plus what, plus 6 this thing Fe3 plus 7 molecules of water, and then the equation is balanced. We have 2Cr, 2Cr. We have 7 oxygens, 7 oxygens. We have 6 Fe's, 6 Fe's. We have 14 hydrogens, we have 14 hydrogens. Let us check the charges are balanced. Here we have -2, which is this, and then 6 multiplied by 2, it's going to be positive. It's going to be positive 12, and then 14 multiplied by positive 1 is going to be positive 14. And then this side, let's balance the charges. 2 multiplied by 3, it's going to be positive 6. 6 multiplied by 3, it's going to be 6. 6 multiplied by 3, I'm lying. 6 multiplied by 3, it's going to be 18. We're going to have positive 18 here, and then for 7 multiplied by 0, it's 0. So now let us add these numbers over here. On your calculator, you say -2, positive 12, positive 12, positive 14. And this side, we get 24. It's 24. Né? And then here, you're going to say 6 plus 18. it is also 24. Therefore, the charges are balanced. If you did the right things, you don't have to balance them. You don't have to do what I'm doing here. If you did the right thing, if you are sure you did the right thing, and therefore this will be your final answer, and then we are done.